the last part of this assignment, it is a self-designed timer controlled LED display with user activated switches. So this project does aim to advance on hands-on project for with the multiple knowledge of the digital electronics and microcontroller programming and embedded systems. So there are a few objectives for this project. Is one, to create a timer controlled LED, display the circuit with LEDs and switches and a timer module, using the design embedded systems on the DE2 FPGA system, which we did already over the other assignments, the prior assignments. So we'll be building this project off of everything that we've done previously. The second is to implement user activated switches that allows the user to interact with the LED display. So we will change like the pattern that it's doing or the LEDs that will be displayed, and then develop multiple LED patterns. Oh yeah, so I just mentioned that. And then a user-friendly interface for selecting LED patterns. So go into the programming portion. So here we have our setup that's pretty similar to all of the other ones. The only difference now is that I actually created a function to change the timer. That way, it's just easier than copying and pasting, because you can just multiply the time here, whatever the time you put in is. So as usual, stop the clock, load the timer value, and multiply by the time that you want it to be in milliseconds, and then as usual, control all of the periods and then turn the timer back on. So we'll do that here, and we have our initialized timer, and then our IC ISR, and then goes into the timer ISR. So the timer ISR is actually checking the mode of the switches. So it's going to do that, and if the mode is not activated for any of these, then it's just not going to run. The timer is going to keep continuing and going through here. Just have the highest priority, so this is really important to have here. This is where all of the lights will make the changes, or this is where the LEDs will actually display and do the action that it needs to do. So if the switch was 1 or the switch 0 is on, then it will come back to the timer, and then the timer will read that the mode is on 1, so it's going to scroll left. That's the first action it will do. If the switch 1 is on, then it's going to scroll right. Switch 2 is on, it's going to go both ways, and then switch 3 will it's right here, so it'll be a blinking light. So in order to get there, we need to also consider that we need to have the switches as interrupt. So we're going to have 17 here for all switches, just like the last assignment. And then as usual, initializing the keys. This didn't change from the last program, so we're using the same one. Everything goes into handle button interrupts, so this is where we check the edge capture for the keys and the switches. So if the key is this or that, then it goes to this corresponding key ISR, and each key ISR is still going to change the speed at which it's blinking, or whatever the pattern is that the user will input. And then it will also check the edge capture for the switches. So whatever switch is high, it will go into the switch ISR. Just one switch ISR. It only can be between these four, because there's only that many patterns that were created. And then as usual, create a debounce for checking the edge capture. Then here's the key ISR. It's creating all the time intervals that the user can input. There's only 3 keys, and then the switch, it's checking the switch base, and then also it's reading to it, and then writing to clear the edge capture, the switch base, and then just since whatever your input is, if it's 1, and checking the bitwise value of that position. So when it's 1, then it's 1, or switch 0 would be 1, switch 1 would be 2, switch 2 would be 4, switch 3 would be 8. And so this just allows for the LED to turn off, and then it will go into blinking, which is why I put that there. And then make sure you reset the edge capture. This is the unsigned hex display. It's going to actually display in the timer ISR it's going to display the mode that it will be in. So 1, 2, 3, or 4 onto the 7th segment, and then you make sure you get it clear, and then flashing LEDs for our interrupts. So that pretty much concludes the code, and then now I'll show the demonstration of the board. So here we have the board up and running. We just need to run it on Eclipse. So just waiting for it to compile, and now it should start soon. Oh, well, actually, yeah, it just started. We're gonna flip the first switch on to get it going. So as you can see here, I'm pressing everything. All the switches will change the direction. The pattern that we're given is that it's changing directions of the LEDs that it will go. So switch 0 and switch 1 will go either left or right. Switch 2, however, will go both left and right. And then switch 3 will just have it blinking in one spot.